So today, lesson 24A, rational number operations, day number 4. We're going to continue with product and quotient of rational numbers. A little bit more in-depth look at that. And the reason why am I learning this is totally filled in. It's the same one that we used yesterday. All right, so let's get started here. Some background knowledge. This is one of the things we talked about yesterday. How to multiply mixed numbers or rational numbers. And we wanted to make sure that we utilize the fact that we can do some cross-reducing, because sometimes in 6th grade we're taught to just multiply straight across, and it sometimes will create more work because we end up, especially as the numbers get bigger and bigger. So cross-reducing or cross-canceling or whatever you want to call that. And then just make sure we convert back to mixed numbers. And so these are a couple of problems that we reviewed and talked about yesterday. And then we talked about the fact that when we're multiplying and dividing, whether it's mixed numbers or decimals, that we just want to follow the rules that we discovered when we were multiplying integers. All right, so some background knowledge from 6th grade. I've got two math problems up here. One is division, one is multiplication. And we're just putting some terms, some things that you should have talked about in the 6th grade. In the first problem, the 16.8, we refer to that as the dividend, 1.4 as the divisor, and this is where you should be copying stuff down. And of course, 12 is the quotient. Quotient is typically referred to as the answer to a division problem. And then 14 times 8 equals 12. 14 and 8 are both what we call factors of 112, because the product of the product of 14 and 8 is 112. So 14 is a factor of 112, 8 is a factor of 112, and 112 is the product. And the reason why I'm reviewing this from 6th grade is we're going to throw out some of these terms as we're going through the problems today. Okay, so let's get started with number 1. Number 1 says this. It says, will the product of 3/4 times 1/4 be bigger or smaller than each of its factors? Now, I would like you to try and think about that without actually finding the answer, okay? I want you to think about that for a second. Will the product of 3/4 times 1/4 or the product of 3/4 and 1/4 be bigger or smaller than each of its factors? All right, have a quick discussion with your shoulder partner. So the question is, will the product of 3/4 and 1/4 be bigger or smaller than each of its factors? Well, bigger or smaller? What do you think? Okay. And you are correct. The misconception for some people is that, well, when I multiply two things together, the product is always bigger than what we started with. Well, that's not always the case. It all depends on what the numbers are. So it's going to be smaller, because one way of thinking of it is the way we thought about things yesterday, is that you're finding 3/4 of a group of 1/4. Think about that for a second. We were showing that on a number line. 3/4 of a group of 1/4 will certainly be smaller than that. And if we actually found the product, it would be 3/16. And 3/16 is smaller than both 3/4 and 1/4. So here's what I want you to do now. We have number 2 and 3 and 4 and 5 and 6. They're all similar in nature to the kind of thinking that goes into what we just talked about in number 1. So I want you to do 2 through 6 with your shoulder partner. I'll get back to you in about 3 or 4 minutes. 2 through 6. Number 2, it says to explain the value of the product of 3/4 times 2. Will it be bigger or smaller than each of its factors? And as I said, after number 1, these are all similar in nature. And what you should have come to is the conclusion that it will be bigger than 3/4, but smaller than 2. And if you were actually to figure that out, you would end up with 1 1/2 for that product. And that's proving that it is bigger than 3/4 but smaller than 2. Number 3, Explain the value of the product 3/4 times 0.5. Will it be bigger or smaller than each of its factors? And then actually answer without actually finding the product. Well, kind of like number one, it will be smaller because you're finding 3/4 of a group of 1/2. Because remember, 1/2 is equivalent to 0.5. And if you were actually to find that, that would be 3/8 or 0.375. Number four, will the quotient of 3/4 divided by 1/4 be bigger or smaller than each term? And it is bigger than both because there are three groups of 1/4 in 3/4. And that's another misconception. Just like in multiplying, like I mentioned with number one, there's a misconception sometimes that when you are multiplying, the product will always be bigger. And there's also a misconception that when you are dividing, the quotient will always be smaller. Well, that's not always the case. It depends on what you're multiplying by with products, and it depends on what you're dividing by with quotients. And you can see if we actually do the division there, we end up with 3. Number 5. Will the quotient of 3/4 divided by 2 be bigger or smaller than each term? It is smaller because there are 3/4 is 2 groups of 3/8. You're dividing 3/4 into 2 equal groups, and then if we were actually to do the math, we would clearly see that that would be the case, because 3/4 divided by 2 is 3/8. And then, number 6. Will the quotient of 3/4 divided by 0.5 be bigger or smaller than each term? And this is much like number 4, actually. It is bigger than both because there are 1.5 groups of 0.5 in 3/4. And if we were to do the math, we would see that that would be the case, because we end up with 1.5. All right, so now we're going to return to practicing a little bit of estimating. And in my opinion, that's one thing that too many students don't at least double check really quickly by estimating in their head to make sure that their answer makes sense. And much like the time that we did this before, I'm going to tell you that I'm not going to make you estimate every single problem. You only have to estimate if you're asked to do so. But there are many times where you should be estimating in your head just to make sure that your answer makes some sort of sense. So if we were asked to estimate -9 times -8 and 1/4, and this is not anything new as far as the idea of estimating, we could estimate the product to come from -8 times -9, which of course is positive 72. And so we would say that that's approximately 72. And then if we were actually to do the math, and we've already talked about the symbol for estimating, but if we were actually to do the math, we better get something that's close to 72. And 74 1/4 is reasonably close. So that means that more than likely we've done everything correctly there. All right? So I would like you to do number 7 and number 8. I would like you to estimate, then find the actual answer, and then we'll shoulder partner what we have for both of those situations. When I was walking around, I was focusing more on the estimate than I was the actual product or quotient there, just to see what some of you were coming up with. But when I estimate here, I estimate -3 1/3 to be -3 and 7/9 to be 1. And so that would give me an answer of approximately, in my estimation, approximately -3. And then the actual product should be -2 and 16/27. Okay? Number 8, we were supposed to do the same thing, but this time with a division problem. My estimation would look something like this: 5 divided by -1, which of course is approximately -5 as far as my estimate goes. And then the actual quotient would be -7. Okay? All right, so let's go to the next page of your notes. And we're going to try and see if we can recognize some sort of a pattern here. So we've got a whole bunch of division problems, and I would like you to quickly find the quotient to each of those. There are 12 of them there, and then we'll have a quick conversation about what we noticed there. So I'm about to have you have a conversation about this. Obviously, in every single one of these problems, the dividend is the same, right? The dividend is 12 with every single one of these. It is the divisor that is changing. That should be clear to you. Okay? Have a quick conversation of some things that you may be recognizing as we work from A down to K. I'll give you about 30 seconds. First. I don't think that was too difficult. So would anybody like to volunteer what they kind of came up with? No? Yes.
All of the answers relate with 12. For example, everything from A through F goes into 12, and everything from G to K is a multiple of 12.
Okay. What about in terms of numbers getting bigger or smaller or things like that?
When dividing by fractions, the numbers are bigger.
Well, we have to be careful with this idea of fraction. I stopped somebody not that long ago, 2 or 3 lessons ago. They were throwing out the idea of fraction, right? Technically, 120,056 over 3 is a fraction, right?
The smaller the number you divide it by, the bigger the number the quotient is.
Okay, good. And that's what I was hoping that everybody would notice. I'm not sure if that happened or not, but you should notice that for a given dividend, the smaller the divisor, the larger the quotient, and the larger the divisor, the smaller the quotient. So now let's turn to number 10, where once again the dividend is the same, but the dividend is not 12 anymore. It is 1/2. And let's see if we can notice something similar to what happened in number 9. So quickly go ahead and find all of the quotients, and then we'll have a quick conversation with our shoulder partner about what we noticed. So let me go ahead and put the quotients up here. And so as you just said, the same thing reversed, and that is pretty much it. You should notice that for a given dividend, the smaller the divisor, the larger the quotient, and the larger the divisor, the smaller the quotient there. So now that leads us to something we talked about a few days ago, where I defined to you what a rational number is. And this was the definition that you were given in the 6th grade, but the official definition of what a rational number is, as I get through the rest of this, is this. It's any number that can be written in the form A over B, where B cannot equal 0. And I said to you in a few lessons, we are going to need to have a conversation about what happens when B is 0. In other words, when the denominator of a fraction is 0. Well, some of you may have been told what it actually is last year, but the bigger question, I think, is do you understand why it is what it is? So I don't know if any of you know what it is or not, but have a quick conversation with your shoulder partner, and let's see how many of you actually know what it is. I heard a lot of 0. Well, it's not 0. What is it?
It's impossible because you can't multiply anything by 0 to get 12.
Yeah, that's good thinking, and actually that's the way that I'm going to kind of explain it. We refer to quotients like that as undefined, and I know you've got some blank areas you're supposed to fill in your notes. If 12 divided by 0 were actually 0, then that would mean 0 times 0 would have to be equal to 12, and that obviously is not the case. Any non-zero number divided by 0, we define that to be undefined. And let me just show you kind of mathematically why that is. 0 divided by 12 is clearly 0. And if we work backwards and think multiplication, creating a multiplication problem from a division problem, 12 times 0 is clearly 0. That's one of the reasons why 0 divided by 12 is 0. Just like 8 divided by 2 is equal to 4, because 2 times 4 is equal to 8. But if you think that 12 divided by 0 is 0, then as we've already talked about, that you would be saying that 0 times 0 is 12. Well, clearly that's not the case. So the next question might be, well, what times 0 is equal to 12? And the answer to that, of course, nothing. And so we term that to be undefined. And so the next question that I have for you, And there's been a lot of debate over this for a very long time. But we'll get to that in just a second. You've got 1, 2, 3, 4, 5 questions as examples in your notes. Can you go ahead and answer all of those? 21 over 0 is the first one. Go ahead and answer all of those, and then we'll go through that one problem that I'm referring to. All right, 21 over 0 is what? Tell me, please. Undefined. Negative 17.2 divided by 0 is what? You guys need one more? Okay. 0 divided by 15. 0 divided by 3.3. And then the question that I was referring to, 0 divided by 0 or 0 over 0. Been a lot of debate about that exact issue right there for many, many years. So I have something that I'm going to send you home with. And that is this.